Thank you for having me here today. I hope my talk will be less painful and more pleasant. I am going to be quite technical, and I'd just like to get an idea who among you have got a biological background. Okay, the rest can go. Hopefully I will be able to put in fairly simple terms what I'm trying to get across here, and that is that addiction and nicotine addiction is a no-no, not only in the workplace but wherever you are. It's absolute poison, and I'm going to show you why in the next few minutes. I'm also going to explain to you through the different sections of my talk. First of all, I think it's important to know what substance abuse is, known mainly by laymen as addiction. And I'll use the term addiction, although it is not correct. There's a lot of problems with addiction. I'm also going to talk about how the brain interprets addiction, why I use nicotine as an example of addiction, and why nicotine addiction is a no-no in the workplace. What is substance abuse? Well, the word addiction comes from the Latin word addictere, which means to be bound over or enslaved. And addiction is used for enslavement of the person by the particular drug, and now we're beginning to realize that other behaviors are also addictive. In short, addiction is nothing more than the will of the person who's addicted to get pleasure from the drugs instead of using their normal physiological processes. They're not satisfied with the normal drives, they just want to shortcut the processes. Unfortunately, addiction is an unfortunate term because it has become overlaid with moralistic and other issues, which certainly does not help the understanding, because even most scientists until very recently regarded addiction with a certain moralistic feeling that it was somehow due to somebody's weakness of character and therefore it's their own fault. It's like somebody saying to a person who's depressed, you must snap out of it. That's not what it's all about. But the problem is, because it's had this long history, since almost the dawn of science, where people regarded taking mind-altering substances as either something in the realm of a shaman, or in later centuries of moral turpitude, it has got a bad name. And when people say they're studying addiction, they begin to think, like most people think, that psychiatrists are nuts, that you've also got a problem. Incidentally, psychiatrists often are. Dependence is a much more accurate name for it, and I want to, particularly when it comes to tobacco addiction. Nonetheless, just for my own convenience, I'm going to refer backwards and forwards to addiction. But please excuse me for being very unscientific. I'm sure everyone in this room has experienced a withdrawal state. A withdrawal state accompanies the sudden withdrawal of the thing to which a person is addicted, and it's accompanied by a range of psychological and physiological symptoms which are very unpleasant, and I'm sure there are very few people in the audience who haven't had a hangover. Well, those who have will remember when they wake up the next morning, they hope they're not going to die, but about 2 hours later, they hope they are going to die. So it's not something. So there's physiological and psychological pain attached to it. This is also a very important fact. Not all substances that produce physical withdrawal are addictive or dependence producing. You can be dependent on certain things, and if you stop them, they will give a definite withdrawal state. And I'll give you some examples. For instance, blood pressure tablets. If you're on blood pressure tablets, as I am, and I think it came from speaking at so many conferences, then if you stop taking them, you find that you get a withdrawal and there's a rebound, and that's a typical physiological withdrawal state due to taking something repetitively. And very importantly, antidepressants are not addictive. I want you to get that very clear, because a lot of lay people and even doctors wrongly think that antidepressants are addictive. And there is absolutely no evidence scientifically for that. In fact, if people, I'm not going to ask anyone here is on an antidepressant. In America, you have to ask who isn't on an antidepressant. But in South Africa, we're more normal, I hope. Antidepressants cause very unpleasant symptoms for those who take them. And a good doctor who's prescribed them will continually have to remind the person or check from the family whether the person is taking their antidepressant or not. Now, if you're living in a house with an opioid addict, you don't have to remind them to take their dose for the day. Now, let's have a look at how the brain interprets pleasure, addiction rather, which is another form of naughty pleasure. First of all, I think it's important to know what homeostasis is. Now, even if you aren't working in the biological field, I'm sure most of you here did some biology at school. Are there any who didn't? Okay, well, it doesn't matter. I hope that I'll be able to make it interesting enough for you to follow. It's not a difficult concept. It really isn't. It's just a nasty, nasty word. Basically, it's all a question of a delicate balance within your body, as the next slide will show you. Right. Homeostasis is the ability of an animal to keep their internal environments relatively constant within normal physiological limits, so that the animal can function normally despite changes in the external environment and also changes within their own internal environments. Obviously, without a reasonably stable internal and internal environment, we cannot function. It's not possible. And you only have to have a cold to see what happens to your concentrating powers, because that tiny little virus upsets your homeostatic mechanisms. Fortunately, not in a fatal way, because you'll recover, but during the interim, it's not very pleasant. And we can do absolutely nothing. Let me give you some examples of homeostasis. A pleasure state is also subject to homeostatic regulation, as are unpleasant states. And there's a state in between, and this is controlled by neurochemicals in the brain. Blood pressure is another example. When we stand up from a lying position, our blood pressure has to accommodate for gravity. And when we lie down, the opposite happens. The blood pressure drops. Let me give you an example. So before I do, it basically allows our bodies to adapt effectively and to respond to change. That's the basic thing that you've got to remember. And here's a young lady who's having a blood pressure taken. And as I said, the blood pressure varies. If you're suddenly upset, it can go up. Sometimes it goes down, and that's when people faint. And that's because the shock upsets the homeostatic mechanisms of the body. Now I'm going to show a slide which might have the effect of raising the blood pressure of the men in the room. I wanted to put something more explicit up, but my wife banned it. And just in case the gentlemen in the room need time to adapt, I'm going to give you that opportunity. And just in case you think I don't cater for all tastes.
You only give a vegan hand.
With no time to adapt.
No. You see, that's the difference between men and women. Women only gradually get excited.
So you don't go from 1 to 10, you go 1, 2, 3, 4, 5.
We won't go into the details at this stage. If you want to see more about that, Saka, read my book. So the brain, being part of the human body, also has homeostatic mechanisms. And that's where we're going to learn a little bit about the homeostatic mechanisms of the brain, which allow the brain to adapt to changes and control changes within the body, because it itself is a very important homeostatic organ. And how does it do so? It responds by changes in the release of various chemicals or neurotransmitters which influence brain function. And these neurotransmitters also influence other physiological functions further down in the rest of your body. And it's an interesting fact that our guts have got very many of the same hormones as our brain has, which can explain why some people are gutsies. Now, let's look at the continuum between pain and pleasure as a homeostatic mechanism. As Denise said earlier, Aristotle in the 4th century BCE realized that there was a continuum between pain and pleasure, and it was a philosophical idea that was carried on later by Descartes and Spinoza in the 17th century. However, it didn't actually become a hard physiological fact until my late colleague and I, in the early 1980s, stumbled on the link, the first physiological link between pain and pleasure. And this was published in a lot of journals, and suddenly, 30 years later, the Americans are rediscovering this and claiming it as their own, which rather amuses me. And, the bottom line, it's there for all to see that the work was done so early, but they don't even refer to our work, which is typical of Americans. And my latest book, and you've got the flyer there, deals with a lot of these findings and explains to the reader how pain and pleasure are interrelated. Although I concentrate a lot more on the pleasure side because I'm a pleasure freak. and I enjoy things. I'd rather not be in pain. So, pain and pleasure are extremes of the continuum, and I'm not only talking about physical pain. So-called psychological pain is also on the continuum. And at the other extreme, sexual ecstasy, and the gurus say that it's even better, and it brings to mind the Playboy joke where a young man, which is common in my youth, who climbed up this high mountain, and you can see the clouds, and there's a guru standing there in his orange robes, and the youngster says, "Guru, tell me the secret of life." And he said, "Bonk as much as you can." And this is a picture of my book, and she's just had a sweet. Just briefly, and I'm sure most of you know this, these are the main pleasure areas of the brain: the ventral tegmentum, the nucleus accumbens, and the prefrontal cortex. And you learn more when you read my book. Hopefully, you'll be able to see how these all fit in. And one of the advantages, and this is why I published it on Kindle, is because when you come to a figure in the book, all you have to do is click on it, and the figure of the brain that's relevant to that particular topic will come up. So even for those people who don't have any idea about brain function, I've written it fairly clearly, and people should be able to understand it. Obviously, this is not a book for a quick read. It's not a quick read book, but if you put a bit of effort into it, I think it will reap many rewards for you. Most people know what a drive state is. It is a strong instinct or impulse which prompts an animal to achieve a particular goal, and it is usually accompanied by pleasure. And we all know what the drive states are. I could even ask anyone without flashing this slide on the screen. Obviously, it's hunger, thirst, and sex. When an animal fulfills a drive state, the brain releases various pleasure chemicals, and the most important one are the endorphins and others, and these produce pleasure and satisfaction. Addiction or substance dependence seems to be a perversion of normal drive states, which are now fulfilled only by the addictive drug or behavior. What is a compulsion? Now, most people find this funny, and I once had to give a lecture to an audience on compulsions. And the person who asked me was a naughty lady. And I don't know what she quite expected me to tell the audience, but I tried my best. What is a compulsion? Well, the next clip will show you an obvious compulsion to everyone and an obvious one to the ladies in the audience. For those who who don't know what the other compulsion was. Any guesses? That's to get hold of her handbag, because the lady never ever likes to be without her handbag. So what happens when we become addicted? There is a compulsive and almost irresistible urge to repeatedly use the substance or behavior to which that particular addict is addicted. As a result of this, the brain areas are affected, the areas that produce pleasure are affected, and they become overstimulated by that particular behavior of pleasure. So the excessive pathological pleasure stimulation triggers the homeostatic mechanism of the brain to act as a protective mechanism. So here we're back. This is why I try to give you an introduction to what homeostasis was. Even with normal drive states, pleasures soon disappear, because the pleasure triggers countermeasures, the other homeostatic mechanisms, to bring the systems into balance again. And you only have to think of our early human evolution. If an orgasm went on for an hour, the predators would have just waited until a couple were coupling, and that would have been the end of the race. So these homeostatic mechanisms are protective, and perhaps it wouldn't have been a bad idea. As a result, the overstimulated brain areas eventually become less and less active. In other words, they become dependent on that particular drug or behavior. And in fact, when it becomes very bad, for instance, opioid addicts, they get to the stage where they have to take their drug to function normally, because they have totally exhausted the pleasure systems in their brains. And the pain systems come into the ascendance unless they take the drug. So they're in a constant state of pain if they don't have their drug. So in other words, more and more of the drug is required to fulfill the same effect, because it's destroying the positive side, the pleasure side of the brain. Not irrevocably, but during the time they are addicted. So what happens when the pleasure system is continually active and it suppresses the pain system? So the pain system now becomes potentially overactive. So you've got a very dangerous system here. You've got an almost non-functioning pleasure system and a pack of wild horses being held in check by an outside source. Any addictive substance, e.g. alcohol, heroin, substance abuse, gambling, sex addiction, stimulate the release of reinforcing pleasure substances such as the endogenous opiate and dopamine. Now, I just want to mention, while I'm talking about dopamine, dopamine is not the pleasure chemical. Dopamine is involved with the wanting, the desire. And because when you want something, you're going to expect pleasure, the endorphins are also released. But the actual pleasure hormone are the endorphins and some others. So these hold in check the pain system. The net effect is that we have two disturbed systems, with the pleasure system potentially useless while the pain system is potentially overactive. So something has to give. And you'll see in the next slide what can happen when is overactivity of one or other system. And that's what happens when you have a withdrawal state. So when the addictive drug, such as cocaine, is removed, there are no more pleasure substances in the system. And that's what causes the car to overturn and causes the problem, the terrible withdrawal state. So this is a problem because people who are addicted to, say, nicotine are so frightened of their addiction, of withdrawing, they continually smoke. So they're actually digging a grave for themselves with their hands, literally. So not only are there no pleasure neurotransmitters released, but the pain chemicals are simultaneously released, and they're unchecked, and they're available to activate the potentially overactive pain-brain areas. Just briefly, for those who've got no biological background, a neurotransmitter is merely a chemical signal molecule or messenger that modulates signals between nerve cells, or as they're known in neuroscience or in the medicines, a neuron. They're usually grouped into systems or families because they react with the same kind of receptors and they interact, they are also chemically similar. Receptors occur on the surface of the cell. Neurotransmitters are released from the nerve on the other side of the little gap between the two neurons, and when it attaches to the receptor on the other side of the tiny little gap, or synapse, it then initiates a cascade of events which results in the physiological response dependent on that particular neurotransmitter. And here is a schematic diagram. This is dopamine as it happens, and you will see that there are little vesicles which contain the dopamine. When the electrical signal comes down the neuron, it causes minute quantities of dopamine to be released from those vesicles, which then attach to the dopamine receptors. And the gap between them is technically known as a synapse. And the crucial brain neurotransmitters involved in addiction are the endogenous opioid and the dopamine system. So the endogenous opioids, such as the endogenous the endorphins and dopamine, are involved in all drive states, including the ones that I referred to earlier. Dopamine and the endogenous opioid are pleasure neurotransmitters, but as I explained, it's only in passing that dopamine is actually involved in pleasure. It's part of the actual drive or wanting to do something that causes the endorphins to release. And substance dependent seems to be a perversion of normal drive states to release pleasure neurotransmitters. Why have I chosen to use nicotine as an example of addiction? Well, first of all, this is a business-orientated conference, and therefore people are interested in business. I could have chosen any, but fortunately, nicotine is is an extremely good example of addiction. And the other reasons are that it is a worldwide health problem, and it literally kills millions of people per annum. It is extremely addictive. And you'll get an idea of how addictive in a moment. And it is a major problem in the workplace. A major problem in the workplace. And the next slide, it's a little bit shocking, will show you what happens to your lungs if you smoke. Even if you don't get cancer, and this individual had cancer. Even in people who don't smoke, or who do smoke and don't get cancer, their lungs are black. And that applies to somebody who dies of a totally different illness. And here's an even more practical and immediate reason why you should give up smoking. That graphically gives people an idea of how poisonous smoking is. The next slide will give you a rather comical version of how addictive nicotine is.
Got a light, mate? I'll take care of that.
Right, now to be more serious, in 1988, C. Everett Koop, who was the Surgeon General of the United States, published a report declaring nicotine as addictive as either heroin or cocaine. And I can tell you now it is, if not more so. And the reason why it's so poisonous from an addictive point of view is, just imagine a smoker gives their body a hit every time they smoke. In other words, if you smoke 5 cigarettes a day, you're giving your homeostatic systems a hit 5 times a day. And in fact, it's worse because every puff does the same thing. And that's why it is such a difficult problem. And to help people to quit, it's very difficult. Take it from me. So, nicotine, like any other addictive substances, that is the substance that produces the dependence, addiction, in tobacco users, stimulates the release of reinforcing pleasure neurotransmitters such as the endorphins and dopamine, which artificially hold in check the pain substances, which are now potentially overactive. And that's what causes the big problem with smoking. It's this continual stimulation of the one system at the expense of the other, apart from the fact it kills you physically as well. So when somebody stops smoking, they have the pain systems which are unopposed. And that's why they have the classical withdrawal syndrome associated with smoking. It amuses me because it was only in the late 70s and the 80s that people even thought that nicotine produced a withdrawal state. I kept this back in case everyone's eyes glazed over and they knew I was going to do something about the workplace, then they'd become interested. So we are now going to look at why nicotine is a no-no in the workplace. This was a study published in 2013 in the British Medical Journal, and it tried to estimate the excess annual costs that a US private company could attribute to employing an individual who smokes tobacco as compared to a non-smoker. And it's actually horrific, the difference in price between the two ones. The study examined absenteeism, presenteeism, which you all know is attending but with less function, their costs associated with smoke breaks, healthcare costs, and pension benefits, which usually have to kick in earlier. And there are clear-cut excess costs if you employ a smoker. And this is the result. It costs the average US company who employed a smoker nearly $6,000 US a year as compared to a non-smoker. Now, anyone who employs smokers is very tolerant and obviously doesn't know what charity to support. They would better support their own charity and then give the savings to a charity. As you can see, I'm a great fan of smokers. Another study published in 2017 confirmed the work-related burden associated with smoking and the benefit of smoking cessation in the US, EU, and China with an extremely large sample. So this wasn't, say, 30 or 40 or 50, this was thousands. The study found that smokers reported greater absenteeism in the US and China and greater presenteeism, overall work and activity impairment than non-smokers in all three regions. Quitters show lower absenteeism, presenteeism, and activity impairment in China, and lower presenteeism, work and activity impairment in the US and EU. So basically, smoking is associated with significant work and productivity loss and cost to any business that employs smokers. If you still don't believe that smoking is a no-no in the workplace, clearly you haven't really been concentrating on what I've been saying, as the next slide will illustrate.
It's the same for everyone. But if you don't get this development file finished at the end of the week, then you'll never get it done. I think if everybody pulls together and works a bit of overtime, we'll all benefit in the long run, don't you agree?
Yes.
Let's continue. So saying.
Suddenly she's got his attention. Thanks for listening.